All right, everybody. This is the last part of section 2.2, and it is just graphing functions again, quadratic functions, but instead of it being in vertex form or being in or standard form, this time it's going to be given in what is called intercept form by the book. I prefer to think of this as factored form. And the reason I call it factored form is because the entire polynomial is written as an a value times a binomial, two terms here, times another binomial. So it's a product of three things. Product and factoring are essentially the same thing. So let's take a look at it. You'll see this notation is a little bit confusing. If you can figure out the x value that makes the function 0, there's going to be two different answers for that. Those are called the X-Intercepts, where it crosses the x-axis. We also have a nice little formula here for finding the axis of symmetry, just whatever P and Q are. But let's look at a few examples because I think it will become understandable at that point. So here's our first example. We can see it's got an A value right here of -2. Now that's the same A that we've been dealing with this entire time, which tells us whether it's going to be narrow or wide, and whether it will open up or whether it will open down. In this case, the 2 tells me it opens down. The negative in front of the 2 tells me. The 2 tells me it's going to be narrow, and the negative tells me that it's going to open downward. So let's look at how we figure out what's going to make this function. I should have a f of x in front of this, or just a y. Let's make it y. Okay, so the question is, what would make this function 0? And those would give us the x-intercepts. And it's really simple to do when it's in this factored form. This factor, x plus 3, and this factor, x minus 1, contain the variables. And all we have to do is find out a number that makes either of those equal to 0. And so you just take x plus 3 and you say, all right, what makes u equal 0? We solve it by subtracting 3. X is -3. Now what we've just shown is that when x here is -3, this entire factor would equal 0. And 0 times anything is 0. So we just found out the ordered pair. When x is -3, the y value is 0. And that, 1, 2, 3, is an x-intercept. We do the same thing with x minus 1. We say, hey, x minus 1, what would make u equal to 0? We add 1 to both sides. Well, when x is 1. So when x is 1, y would also equal 0. When x is 1, this factor up here in red, it becomes 0. 1 minus 1 is 0. 0 times anything is equal to 0. So I know if the x value is 1, the y value is 0, and that gives me this point right here. Now let's find the axis of symmetry. The axis of symmetry is really easy. What you're trying to do is find the midpoint of the two x values right here. Okay, so that think of that line right now, it is 4 units long. 1, 1, 2, 3, 4. Half of 4 is 2, so if I was 2 away from one of these points, I would be right in the middle of the 2. And see, these 2 points are symmetric, so I know my axis of symmetry is right in the middle. To find that axis of symmetry, though, all you have to do is remember, axis of symmetry, a vertical line, x equals, all you have to do is add those two x values together and divide by 2, just average them. -2 over 2 is -1. So the axis of symmetry is that where x equals -1. So I now know the axis of symmetry. How do I figure out then the y value, the vertex of it? The vertex is going to be easy. Once I know the x value of the vertex, remember that vertex has to lie on this axis of symmetry. That means I'm just trying to find the y value when x is -1. Let's just run up to our function here, -2. Let's make x -1 plus 3. X is -1 minus 1 in parentheses. Little math, we'll do stuff inside the parentheses first. Multiply left to right. And we'll get 8, -4 times -2. That means our vertex is x is -2 and y is 8. Which puts it right there. And that is enough to graph your parabola. Again, we knew it opened upside down because the negative. We also knew it was going to be narrow because of the 2. Let's do another couple of these. Already in this factored form, or intercept form as the book calls it, we can see it's going to open upside down because of this negative. We just take the factors with x in them. X plus 1, set it equal to 0, we subtract 1. That is, on our graph, x is -1, the x-intercept. So just put a -1 right there, and we'll put a point. Then we grab the second factor, x plus 5. Say, hey, what makes u equal 0? Subtract 5, -5, so our next x-intercept is at -1, 2, 3, 4, 5. So right here. Next thing we're going to do is we're going to find our axis of symmetry, and again we can see it happens right between, so it's going to be right here. But again, we'll just calculate it. We'll just say x, the axis of symmetry is -1, this first x value, plus the second x value, -5, divided by 2. We get -3, which is right here. And remember that it's not a point, that is just our axis of symmetry. So we find our intercepts, we find our axis of symmetry, we take that axis, that x value for the axis of symmetry, and we just substitute it in for the x's in the original function. We find the f, essentially, of -3, which would be negative, that's that guy, parentheses, -3 plus 1 times -3 plus 5. -3 plus 1, -3 plus 5, multiply 2 times 2, looks like it is 4. So when x is -3, the y value is 4, so let's mark 4 up on the y-axis, right about there. Again, the negative tells us it opens down, and so our parabola is going to look something like that guy. Very last one, try to go through it a little bit faster. It's going to open upward because it's positive. It's also going to be wide because of this 1/4. Okay, so it'll be shrunk in the x, or stretched in the x direction, shrunk in the y direction. Let's make our coordinate axis here. And let's just write down these two functions, or these two factors. And you just do them at the same time. And then you can mark those 1, 2, 3, 4, 5, 6. And 1, 2. Right there. Axis of symmetry is going to go right in the middle of those two. And we can see that's at 1, 2, 3, 4. But we can prove it's at 4 by saying the x, the average of these x values, which is 4. Again, this is the line, x equals 4. Next, all we have to do is take that value of 4, plug it into the function. So we are going to find the g of 4, which just means go to function g, right up here, and everywhere you see an x, put in a 4. Go inside the parentheses first, multiply left to right. Half of 2 is a 1 times 2, so we get -2 for an answer. So when x is 4, the function is -2. Let's put a point right there. We know it opens up, and so there is a good enough graph of our function.